Welcome to OpenEdge Database Monitoring. The coders are out to get you. In this session, we're going to talk about some of the ways that coders make a DBA's life miserable, and some of the tools that you can use to guide them to the path of righteous coding and happy users. I'm Tom Bascom. I've been a Progress user, coder, and roaming DBA since 1987. Here at White Star Software, we specialize in simplifying the job of managing and monitoring the world's best business applications. We're also the authors of ProTop, the best OpenEdge monitoring tool in the galaxy. We offer remote database management services for OpenEdge databases and expert consulting services related to all aspects of Progress and OpenEdge. If you need to reach me for any reason, send me an email, tom@wss.com. Thank you, and let's get started with today's session. The sins of coders that impact DBAs tend to fall into four broad categories: bad transaction scope, bad where clauses, keywords that they just can't seem to forget, and this idea that something that works great in development is also going to work great in production. So let's talk about bad transactions. If you have a transaction that lasts more than 1 second in your application, then you probably have a problem. There are three main categories of these sorts of things: transactions that span across user interface interaction. In other words, they run for a long time while the user is busy doing something. Business transactions that are inappropriately implemented as database transactions. These tend to use a very large -L, for instance. Uppercase L, the lock table. And ad hoc data fix routines with poor transaction scope. These are the three main categories of transactions that cause problems in a Progress database. Now, if you have a transaction that is spanning UI, that causes a problem because it drives this out-of-control BI growth that many of us have experienced. There are a lot of applications where the BI file will grow and grow and grow. It consumes disk space to do that. And if it consumes too much disk space, it could crash your system, possibly in a very difficult to recover manner. Usually this is caused by bad coding practices where your buffer or your transaction scope are wider than the user interaction. So you go into a screen and you go to update some data. There's already a transaction running. You don't leave the screen, so the transaction continues to run and run and run. Another option is the business transaction that's been implemented as a database transaction. These are often associated with things that are easily interruptible or which you could restart at will, or a reversible business process. For example, purging old data. If you're purging last year's data, you can start and stop that at any moment. That doesn't have to be an all or nothing database transaction. You can get partway through, say, okay, well, I'm going to finish this tomorrow. And you can go ahead and do that. It's easy to code. Bulk updates are like that as well. A similar sort of a problem is the ad hoc data fix. A lot of times people will just go into the Progress editor or they'll write a quick and dirty little piece of code that will do some sort of an update to fix some data or to patch a problem that they've had. And they might write some code like what you see here. The problem with that code, even though it looks quick and dirty and pretty simple, is that it started a transaction because there was a share lock on that table. You have to carefully control the transaction and make sure that the scope doesn't expand to the sub-procedure that you're running, or else the whole thing becomes a transaction. So when you start ProTop, the first screen that comes up is the dashboard screen. This shows you a lot of interesting information about what's happening with your application. But in particular, it draws your attention to things that are going wrong. But in this case, we see that we have a long open transaction. We see that the oldest transaction is highlighted in red, so that draws your attention immediately. And it's using almost a gigabyte of disk space in the BI file. So clearly we have a problem. But how do we find out more detail on this problem? Well, we use the X command to bring up the active transactions. By bringing up the active transactions, we see a list of which transactions are active, sorted by their duration, And it shows us right away that the 18-minute transaction is at the top. Not only is it an 18-minute transaction, but it's been idle for most of those 18 minutes. So this is probably a transaction which is spanning user interface. Users 848, 448, and 5112 are very similar. They're not quite as old, but they have the same characteristics of being an old transaction that has been idle for nearly the whole time. And then we see that user 512, has not been idle that whole time, only been idle for 2 minutes and 21 seconds. So it did something, and then it has stopped after that. It probably ran for a while and now is waiting for some input. So that might be a hybrid transaction. If you look at user 932, you see that they've been blocked for 8 minutes, and they're waiting on a record lock. They're waiting on a record lock on rec ID 573329268 on the stock out table. And we see that that the blocking statement is line 1549 of IMUPD stout.p. So we know right where that problem is, and we can zero in on it. What else is going on here? User 907, this looks more like an ad hoc data fix or possibly a business transaction that's been implemented as a database transaction because it's been running for 11 minutes, but it's not idle. So it's still out there churning away at things. Another thing that's interesting here is that the line number for the source code is a 6-digit line number. That's enough to make you wonder just how many include files, including include files, are being used in this code. Those are some kind of crazy long line numbers there. So what about bad where clauses? There are quite a few index selection rules, and you can find a lot of talks about it on PUG websites. But one of the most important rules is to remember that equality matches on all the leading components of an index are the way to get the most efficient queries. It's a very simple, but all too frequently overlooked rule. There are many databases which have a leading component of company or something equivalent that was used for multi-tenancy back in the days before multi-tenant databases. And programmers sometimes look at that field, or don't look at that field, and wonder, well, we've only got one company, so I don't need to include that in my query. Leaving out the company name isn't a good idea. If you leave out the company name, you get a much worse result than if you have the company name in there. This illustrates it with a slightly modified sports database that has the company name placed first in the index. If you run the code without the company name takes 707 milliseconds. The code with the company name runs in less than a millisecond. So it's a very dramatic difference. Now imagine that little piece of code being inside a loop that processes thousands of records. You're going to have very, very bad performance day. So if we go to ProTop to take a look at this kind of thing, we see right away in the dashboard that there's a very high level of activity on logical reads, and it's broken into record reads and index reads. So you have about 2 million logical reads per second going on here, and about 1 million record reads and 1 million index reads. So right away, you know that you've got a problem with high activity. This is probably what we call a rapid reader. But how do we get more detail? Well, the table activity, index activity, and user activity screens help to break that out. So we break it out and we see that the table that is being accessed here is the order table at about 1 million record reads per second and a roughly equivalent number of index reads per second. Now, in a way, that's good in that the index reads and the record reads are balanced. So you read an index entry and then you read a data block. So that's as it should be. They're not out of whack there. But it's interesting that the order table only has 700,000 records in it. So it's being churned about 1.5 times per second. That means you're reading it over and over, or you're doing the equivalent of reading it over and over. This is a very good indication that you are doing something that you probably don't want to be doing. And then if we look at the user activity, we can see that this guy named Tom seems to be causing the problem. Most of the block access, about 2 million block accesses per second, which happens to be the sum of the index and table activity, is being executed by Tom. It's resulting in a lot of disk reads, 37,000 OS reads per second. And looks like line 5 of this program called nocompany.ped is the guilty party. So you can zero right in on where the problem is coming from, and hopefully you can instruct the programmers on adding whatever is missing from their where clause at that point. So when you take a look at the code that the client statement cache or some other technique has pointed you to as the root of the problem, there are some things other than bad where clauses that you might run into. These keywords here are some that are at the root of many such performance problems. You may find that the can-do verb is being used. Can-do, when it's used in a where clause, forces client-side selection and sorting. So you're basically having to send all the data over to the client to be selected and sorted. Can't be resolved on the server. Can-do is actually a security function, not a string manipulation function, and should really never be used in a where clause. You may also see that there's a use index. If the use index keyword is in there, then that overrides the compiler's index selection. Sometimes, very, very rarely, but occasionally, use index is something that you need to do. But if somebody believes that they need to use index in order to improve performance, they really need to document that. You need to have some test cases that clearly show that that was a good idea, because most of us are not smarter than the compiler. And in fact, one of the easiest ways to discover performance problems is to search for comments saying that somebody did something to make performance go faster. Anyway, that's just a little side note. The other thing about use index is that it prevents the use of multiple indexes. So if you have a query which could have taken advantage of multiple indexes, use index prevents that. The matches keyword, when used in a where clause, also forces a table scan. So it's, in a way, it's nice because it supports wildcard comparisons, but when you do that, you're basically telling the query engine that it has to look at the entire table in order to resolve the query. And you probably don't really want to be doing that. Now, we've all heard programmers say that something worked great in development and they can't understand why it's not working well in production. ProTop has a lot of features for finding out what's going on in production, specifically the stuff in the upper left-hand corner that we've already gone through. But there are also a lot of features that are very helpful in your development process. And it's always better to stop problems before they get to production. So let's talk about some of that. One feature is the user drill down. If you type the pound or hash key, you can select a specific user and look at their detailed information. You can turn the client statement cache on or off for that user, and you'll be able to look at things like the user's individual session, table, index, and call stack activity, along with any other sessions that they're running. You get information about that one user's logical reads and logical writes rather than the aggregate global numbers that you get on the ProTop dashboard screen, and you see anything that's going on with their locking and their transactions and things like that. So this helps you out in cases where it's not obvious what user is responsible for the traffic, but you're pretty sure that a particular user has a problem. It's also very useful in a development environment where you're sharing things between multiple programmers. You can zero in on your session and isolate yourself from everybody else. There's also something called programmer mode, which is the Control-P key. What this does is change the way that the metrics are shown from being, the activity metrics, from being shown as per second to showing you what the aggregate is. So you turn on programmer mode with Control-P, then you hit a space bar to clear all the counters. You execute whatever code it is that you're interested in understanding the performance numbers for, and hit another space bar, and you'll get the aggregate between those two space bars. Very helpful. Just the sort of thing that programmers need to show them what their code is actually doing. ProTop also contains a bunch of sample code. So there's sample code which will help you to get the user-specific table, index, and statistic for a session. So if you want to instrument your application to be able to track things like the top 10 tables that have been used or the top 10 indexes, that sample code is right there for you to plug in. Having a feature like that available in your application is really handy when you need to debug something remotely. Or temp table usage. So in a modern progress application, you're using a lot of temp tables and pro data sets to organize your data, to cache it locally, to do things like that. And there are statistics available about your temp table usage. They're kind of hard to get to. There's a very arcane API that you have to call, but there's some sample code in ProTop that will help you to do this. And the first time that you do it, you'll type Control-T and you'll find out that it's not enabled by default in ProTop. You have to actually set this environment variable, ttdebug, and you have to make sure that the appropriate startup parameters for your session have been set. Now, within ProTop, it's not necessarily all that interesting. It's not going to tell you anything about your application, but the point here is that it shows you how to instrument your application to provide this data. So once you've done that, you can get useful stuff like the number of blocks that are being used for temp tables, how many creates, how many reads, updates, deletes your temp tables are doing. This is all internal information about the usage of temp tables that might be very surprising. You may not have any idea really what the pattern of usage of your temp tables is. So that's the global overall information. If you hit OK on this, then you get the detailed information, temp table by temp table, where they were created, what procedure created them, how big they are in terms of the byte count and the number of records, how many create, read, update, delete operations have occurred, which is all very helpful in helping you to understand how your application is using that previously mysterious resource called the temp table or ProDataset. The profiler is an enormously useful and very underused tool for digging into performance issues. It's really not all that hard to integrate it into your application in a way that makes it very simple to trigger when needed. So as this message shows, ProTop already has the profiler enabled. Now, this is clearly going to only profile the ProTop session, but again, the idea here is that this is sample code that you can take to your application and set up to trigger. So if you do the profiling here, turn it on, and let it run for a little while, and then do it again, you can find out what the most expensive bits of code in your application are. In other words, where are you spending all of your time? Now, if you don't want this report, or maybe you just don't like character interfaces, that's okay. You can take the output file and you can hand it over to PDSOE's profiler tool, and you get this nice fancy GUI that will let you evaluate things 6 ways from Sunday. Most of the time, I just want to know what the top 10 lines were, but sometimes you want to know what the call tree is and things like that, and all that data is there and available. And the point of this isn't so much that you should use this code as is, but rather as a jumping off point. We've implemented this for clients as hotkeys in interactive applications or externally triggered startup routines in batch programs, in app servers, and in various other ways. So if you want to do this, feel free to reach out. I'd be happy to help figure out how to do it. The code's not really all that complicated. The samples are right there in the ProTop directory, so feel free to give them a shot. So to summarize, we should have learned how to recognize bad transactions, how to recognize bad where clauses. We should have found some keywords that we don't ever want to see in code again. And you should now have some tools that you can use to show your coders the way to the path of righteous coding and happy users. If you don't already have ProTop, head on over to WSS.com, select the package that's appropriate for your platform, download it, follow the instructions, and get started. Thank you. And if you have any questions, let's see you in the chat window or send an email to tom@wss.com. Thanks a lot.